Okay, so we are going to look after the review of Laplace transform because it is the most important topic which will be required for the numericals which we are going to do in the control system. So let's see. First, we will start with what is Laplace transform. So as we remember, we had discussed in the classroom that basically the Laplace transform is nothing but it is the tool which is used for representing the frequency domain when we have a time domain function. So for converting any time domain function into frequency domain, we will be using a Laplace transform. Now Laplace transform is actually I can say originated with the help of a integral transform. Now how does the integral transform looks like? So integral transform looks like this. Just one second. So your integral transform looks like this, where you have g of alpha is equal to integration a to b f of t into k alpha comma t of dt, where g of alpha represents the output, f of t represents the input, and the relation between output and input is given by a integral kernel. On this side, the scientist who has developed the Laplace transform is Simon Laplace. His photograph is there. Just for the reference, I have kept it over here. Now, how does a Laplace transform look like? So when we say Laplace transform, we say that it converts time domain into the frequency domain. So frequency domain is always represented by S. Carefully you note down this, that left side, left will be in a small case, and whereas the frequency domain f will be in a capital case. So when I say I am taking a Laplace transform of the function f of t, it will be equal to f of s. However, I need the detail of f of s, like how f of s will look like. So if you note down over here, it can be seen that f of s is nothing but it is equal to the integration of minus infinity to infinity f of t into e raised to minus st dt. So while you write in your assignment page, you have to write along with this one thing which is very important, that similar to this, the above equation, f of s is nothing but it is the output, f of t is nothing but it is the input, and e minus st is nothing but it is the integral kernel. Now what do you mean by this particular s? Like what is s in frequency domain? So s is consisting of two things. One is tau plus j omega. So tau is your real part, omega is your imaginary part. Okay, we'll see what is this s is equal to tau plus j omega as we move further in the lectures. Okay, now let's take one example. We will find one Laplace transform. So what is the condition given? That find the Laplace transform of a unit step function. Now what do you mean by unit step function? So unit step function is like what we have to find, given is f of t is equal to u of t. Now what we have to find, what is the Laplace transform of a unit function. So if you remember, unit step function is nothing but it is 0 for t less than 0, and it is 1 for t equal to or greater than 0. How diagrammatically it can be represented? It can be represented like this. So if you note down over here, it is for 0 it is 1, and above 0 it is again 1, below 0 it is minus it is 0. Okay, for below 0 means minus 0, it is 0. So this is how a unit function looks like. Now let's take a integration in the formula format, like how your Laplace will be. So what we have to do, we have to take this particular formula. This formula we will be using. So how it looks like, f of s is equal to minus infinity to infinity f of t e raised to minus st dt. Now what is f of t? F of t is nothing but u of t. Now it is an integration from minus infinity to infinity. Now as per the rule, if you remember, of the integration, we generally divide it into two parts, from minus infinity to 0 and 0 to infinity. Now for minus infinity to 0, which is minus infinity to 0, your output is 0. However, from 0 to infinity, your output is 1. Okay. So what will happen? This particular integration part will not come into picture. It will automatically become 0. Only the integration of this will come into picture, which is 0 to infinity. And what is the value of that? U of t is equal to 1. So it will be 1 into e raised to minus st dt. Now if you remember the integration of e raised to n का इंटीग्रेशन क्या होता है? सो e raised to n का इंटीग्रेशन क्या होता है? e raised to nx, integration of e raised to nx is equal to e raised to nx upon n. So in this case, if we go like this, what will happen over here? So it will be minus 1 upon s e raised to minus st, which is this e raised to minus st has it is. ये आपका n हो गया s, तो ये डिवीजन में आ गया, बिकॉज इट इज़ माइनस, सो वी आर टेकिंग माइनस. नाउ इट इज़ 0 टू इन्फिनिटी. नाउ अगेन, अगर आपको याद नहीं है रूल्स एक्सपोनेंशियल के, तो इट इज़ वेरी सिंपल. e raised to 0 is equal to 1. So e raised to minus 0 will be equal to minus 1. Okay. E raised to infinity or minus infinity is equal to 0. Now we will substitute 0 over here in place of s. Then we will substitute infinity in place of s. And we will substitute this value. तो अपने को आंसर क्या आएगा? e raised like Laplace transform is equal to 1 upon s. कैसे आया? ये 1 कहाँ से ये 1 आप रखोगे यहाँ पे, तो ये माइनस 1 हो जाएगा. माइनस एन माइनस विल बिकम वॉट? इट विल बिकम प्लस. So it will be 1 upon s over here. So Laplace transform of unit step function is equal to 1 upon s. ऐसे आपके बहुत सारे Laplace के functions हमको use करने हैं. So whenever we have the numerical, we will have the following Laplace transforms. Okay. So for example, your Laplace transform of e raised to at is equal to 1 upon s minus a. Your Laplace transform of sin at is equal to a upon s square plus a square. Laplace transform of cos at is equal to s upon s square plus a square. So on. So we are going to use this particular table for many of the numericals which are going to come into the picture. Now, similarly, we are also going to discuss about inverse Laplace transform. Inverse Laplace transform is to obtain time domain from frequency domain. Okay. So यहाँ पे आपके क्या रहेगा? टाइम डोमेन रहेगा यहाँ पे, और यहाँ पे आपके क्या आ जाएगा? दिस विल बी फ्रीक्वेंसी डोमेन विच इज़ रिप्रेजेंटेड बाय एस. सो इट विल बी एफ ऑफ टी इज इक्वल टू 1 अपॉन 2 पाई जे. दिस इज एस टू एस बिकॉज टाउ माइनस जे ओमेगा टू टाउ प्लस जे ओमेगा एफ ऑफ एस ई रेज टू एस टी ऑफ डी ऑफ एस. However, we are not going to use this particular formula for getting inverse Laplace transform. When we are going to solve Laplace transform, which is a inverse Laplace transform, we are going to use partial fraction method. Is it okay? So time being, we will stop over here. In the next video, we are going to see the property of the Laplace transform. So after completing this video, move to the properties of Laplace transform. Thank you.